All right, hello everyone, and welcome to the presentation of our demonstration, XDB in Action, Decentralized Cross-Database Query Processing for Black Box DBMSs. This is joint work with colleagues from the TU Berlin and the Bifold Institute, the IIT Delhi, and the IT University of Copenhagen. And this work is actually dedicated to our colleague Jorge, who unexpectedly passed away during the course of this work. All right, so let me start with today's data landscapes in organizations. So typically organizations have multiple databases across the world, and they need to analyze those data stored on those databases. And use cases range from intra-organizational, where we have multiple teams or branches collaborating, to inter-organizational, where organizations need to enrich their data sets with external data, for example, through data marketplaces. And data marketplaces are actually accelerated by the fact that major cloud and database vendors are actually pushing towards this direction. And when we talk about cross-database analytics, we refer to queries like this. So here is a query where in the from clause, I have tables from different database management systems. And here I have what we call cross-database operations, essentially join predicates over tables that reside on multiple systems. And what we need from today's systems is, of course, good runtime performance, little resource consumption, being non-intrusive to existing systems, and processing these queries on disparate data. And there are quite some approaches out there that tackle some parts of this goal. And now I'm going to walk you through each of them and discuss why they're not a good fit. So first of all, we talk about federated databases, which support heterogeneous sources. So this all started with Guido Wiederhol's vision about mediators and went on to the CIMIS research project and the Garlic project at IBM. That introduced the mediator wrapper architecture, and today's federated query engines are based on exactly those principles. For example, Presto or Trino, Apache Drill, Calcite, etc., are all based on these principles. And what happens there is that we have centralized query processing, which means that data is pulled from the sources to a mediating engine, which needs additional resources. And this, let's say, pulling of the data results to expensive data movement. So this is not exactly what we want. Then we also have distributed databases where we have this nice inter-database communication, but this is for tightly coupled DBMSs. So each DBMS needs to be of the same type. And finally, we also have peer-to-peer DBMSs, which also support heterogeneous sources, support inter-database communication, but need additional query execution components and are also not primarily targeted at SQL queries. All right, so what about our goal? We see that current approaches do not really fulfill all our requirements. And this is why we propose in situ cross-database query processing and XDB, our system, which I'm going to introduce to you now. So you can read about XDB in the ICD 2023 paper, and XDB is a system that supports heterogeneous sources and inter-DBMS communication, this way improving runtime performance and decreasing the data movement. And XDB is actually a thin middleware, and it offers a mediator wrapper-like user interface. So essentially, it's a drop-in replacement for your existing queries. And we have a centralized optimization approach. So we optimize the queries in our middleware and delegate instructions to the underlying DBMSs such that they can then execute the query in a decentralized fashion. And how this works, I'm going to show to you now. So query optimization in XDB is done in 3 phases. In the first phase, we optimize the plan logically. So essentially, we perform selection, projection, push down, and join reordering on based on simple statistics. Then in the second phase, we annotate the plan. So this means we assign an operator, a DBMS to each operator of the plan. So as you can see here, each operator is annotated with a particular DBMS. And then in the third phase, we finalize the plan. Essentially, we merge those operations with the same annotation into tasks, and we combine them all into what we call a delegation plan. And now we are ready to delegate the query, and for that we need to rewrite our plan to DBMS specific statements. So as you can see here, we have on the left the plan we had from before, and essentially we translate all the tasks into views. So essentially you can think of it as a lazy evaluation. So we first register instructions as views on the DBMSs, and we translate data movement operations with foreign table statements, which come from the SQL Match standard, which allow the databases to access data from other databases. So we do all these steps until all our tasks and data movement operations are translated. And as a result, we get the XDB query. So essentially, we have a select star from last view statement, where last view is the view that got registered on the last DBMS. And when we now execute this XDB query on the DBMS where the last view was registered, this will result to a view cascade evaluation, because the DBMS is going to ask for the foreign data on the other DBMS, and so on and so forth until the last DBMS is reached. And then this results to this nice decentralized inter-database execution pipeline. All right, and now that we looked at the concept of XDB, it's time for the demo. And for this, my colleagues Leonhard and Joel will guide you through the user interface and the demonstration scenarios.
Hello and welcome everyone to the practical part of the XDB demo. I'm Leonhard and I'm going to demonstrate the capabilities of XDB using a web interface we built. XDB is geared towards businesses that have data spread out over multiple databases and need to combine them, but find building a dedicated data warehouse too expensive. Current mediator wrapper systems run into a lot of unnecessary data over the network. If you're using a cloud computing provider, this can cost you a significant amount of money, as you have to pay for this traffic. In our example setup, we have 5 databases running, 3 Postgres and 2 MariaDB databases. Currently, only one MariaDB database is registered, so let's add the other one. Once XDB has retrieved all necessary data from the database, it is displayed on the map with connections to all other databases shown as well. We're going to demonstrate later how we can remove connections between databases to affect the choices of the query optimizer. Of course, we can not only add databases, we can also remove them. We click on Edit Topology and click on the database that we want to remove. Let's move over to the query interface to execute a query. Here we can enter a query in the text box. Once done, clicking on Run will make XDB execute this query across all used databases. The result is displayed below. As you can see, this query uses data from PG1, PG2 and MDB1. So XDB can combine data even from databases from different vendors. On the left side, we have a list of all currently registered databases. Clicking on one of them expands it and shows you all available relations. These relations are discovered automatically, no further user input is required. Now, we can not only execute queries, we can also analyze the execution plans. For this, we click on Explain, which automatically takes us to the last screen. Here, the big advantage of XDB becomes clear. We do not need a mediator. Instead, data is moved freely along the execution plan between the databases themselves. For example, at the bottom, we can see that data from PG2 and MDB1 is combined first on PG2. This data is then joined with data from PG1 on PG1, after which more data from PG2 is added. This results in a query plan that only moves a minimal amount of data through the network. But what if the connection between PG2 and MDB is really bad or expensive? We can force the optimizer to try to find a plan that avoids this direct combination. For this, we go back to the topology setup and click on MDB1 and then on PG2. As you can see on the map, the connection is now removed. If we go back to the query interface, insert the query again, click on Explain again, then the query optimizer will give us a different execution plan. As we can see, now PG1 is used as an intermediate for the query, more akin to something that you would find in Presto or Trino. But in contrast to such a mediator wrapper system, for us this is really only a fallback option if the network topology necessitates it. By default, the more efficient and distributed plans are used, as a result in greater cost savings. Let's take a more closer look at those. In the query interface, we have on the right side some graphs on the cost calculator. They're loaded by default with the data from TPCH with a scale factor of 10. We could also run other queries by adding them to our workload and then executing them. But as we are only using small scale factors to keep the demo practical, the results wouldn't be meaningful. So let's talk about the results that are also in our paper, because they use a larger scale factor that is more realistic for analytical workloads. We can observe that runtime with XDB can often be half as slow as with Presto. Furthermore, the amount of data transferred to the network is at least an order of magnitude smaller, if not even 2 orders of magnitude, as with TPCH Query 3. Below, we can assign a price to megabyte of traffic. So let's take 0.2 cents. This results in a price of about $1.85 for running these queries on XDB, and the price of nearly $29 for Trino, 15 times the price of XDB. What we have not discussed until now is how XDB decides on which database to execute a join. In the given logical execution plan, it could always take the database of either relation. Furthermore, it has to decide on whether it materialized the results in before, or whether a join should be pipelined. While there are many options that we want to explore in the future, in this demo we use a machine learning model, more specifically random forest. Joel is going to explain this now in more detail and demonstrate how you can add more data to it.
Hello, I'm Joel Ziegler. Let's take a look at how a user can train XDB to generate optimal plan annotations. Here under the Topology Setup tab, a user can press on Upload Workload. XDB expects a training workload which is representative of a production workload. After pressing Upload, XDB starts generating training queries based on the training workload. On the upper left, you see in the console that XDB is working. It executes the training queries between the different database management systems. So, we use currently a random forest model for classification. In specific, XDB has to decide for every expression of a logical plan on which database system to execute that expression and in which mode the data should be transferred. After XDB finishes executing the training queries, the user sees the execution log on the right side. Here you see for every training query the join that got executed, on which database management system, the data transfer mode, runtime, and data about the relations. So, and that's how a user trains XDB for plan annotations. Thank you.
Okay, so that was the demonstration. Let me wrap up this presentation. We presented XDB, our prototype for in-situ cross-database query processing that acts as a drop-in replacement for existing mediator wrapper systems and queries. We propose a centralized three-phase optimization and a decentralized execution phase that is supported by the SQL MED standard, which is also implemented by most DBMSs out there. And we do not require media engine for query processing, which results to performance improvements and to less resource utilization. And of course, you can check all the details in our ICD 2023 paper. I would also like to mention that XDB is part of the PolyDB project, and we're actively developing it. And if you're interested, I invite you to check our website. Thank you for listening.